Hello, my name is Mitchell Kriege. Today I'm going to be speaking about the linear relationships between the anthropogenic impacts and freshwater mussel communities in the Ohio River. The study area is the Greenup Pool of the Ohio River. It's a 62-mile pool situated in the Middle River. It encompasses states of Kentucky, Ohio, and West Virginia. The red circles there represent the two dams that separate out the pool. The circle on the left is the Greenup Lock and Dam in the lower end of the pool. The circle on the right is R.C. Byrd Lock and Dam in the upper pool. For our design, we followed the West Virginia protocol using a series of 100-meter long transects spaced 100 meters apart. Each of our sites is 500 meters long for 6 transects. Within each transect, we surveyed a 1 meter wide swath. Each 100-meter transect was split into 10-meter intervals. So we surveyed the pool in 2017 and 2020 with 37 randomized sites. Green sites in the upper pool here were sites that were surveyed twice, once in 2017 and once in 2020. All the yellow sites were only surveyed once. So some results. As I said, we had 37 locations. We had 216 100-meter transects and surveyed approximately 21,000 square meters between the two survey years. We collected 24 species live and 7,750 live individuals. That included 18 live federally endangered Plethobathus siphius. Here's a little look at the percent relative abundance. The evenness here is actually really interesting. You've got two species, Reflexa and Pustulosa, that dominate the percent relative abundance, but then it really evens out throughout the rest of the unionid fauna. Greenup Pool has a long history of anthropogenic impacts. It has several large metropolises, including Huntington, Ironton, and Ashland. It also has a long history of industry. It contains several large steel mills and factories beginning in the 1920s that were active up through the 1990s. Greenup Pool is also heavily utilized in the shipping industry. In the early 2000s, it was the busiest inland port in the United States. This is mostly due to the influences of coal in the region. This is a shot here of the Big Sandy, which empties into the Greenup Pool. Many of the barge-related activities in this region were due to exports of coal. So on our map here, you see an overview of all of the barge-related impacts in the pool. Each of these represents either a barge pin or tie-up, or some sort of bank-related activity where there is a loading into the river. Here's a little closer look at the middle Greenup Pool, which is sort of the hub of activity. You can see there's a vast number of barge moorings and tie-ups throughout the lower middle pool, particularly where the Big Sandy River comes in the bottom left hand of the screen, right here. The lower pool, you've got Greenup Lock and Dam right up here. There is quite a bit of activity here, but it starts to wean out as you get towards the dam. Then we've got the upper Greenup Pool, which is extremely remote and heavily forested. R.C. Byrd Lock and Dam right here. Basically, you've got about 15 miles of fairly pristine habitat for unionids with very few anthropogenic impacts. We also have a large number of CSOs in the Greenup Pool. We've got the cities of Huntington, Ashland, and Ironton dumping combined sewer overflow into the river during heavy rainfall. There's also a number of other small cities which have CSOs but do not have any sort of mapping of their facilities. Using our extensive survey data set, our main goal was to create a predictive measure of good versus bad unionid habitat in a large river system based on anthropogenic and natural influences. To understand the predictors of good versus bad unionid habitat, we performed a principal component analysis using 10 predictive variables that were all equally weighted. These variables ranged from detrimental to unionids such as CSO inputs to factors that may not be so detrimental such as downstream distance from a dam. We also focused in on the tributaries in the systems. We've noticed in the past that unionid communities taper off or increase based on their distances from the tributaries. So we're interested in seeing how the inputs of large versus small tributaries played into patterns in unionid distribution. So looking at the PCA of the unionid communities, our first three variables explain 69% of variance within the communities. So looking at the PCA here, you can see our unionid communities split out into two distinct groups. You've got your group here with nervosa, crassidens, A-lig, syntaxia, and then another large group down here with civius, linealata, pustulosa. This upper group contained a number of individuals that were found mostly in the middle pool, particularly around Huntington. This 309 site was kind of an interesting driver of that group. It was right below Sims Creek, and the site actually had some impacts above it, but we believe that the creek may have been dumping in enough clear water or fines to protect the community there. And it was interesting, we actually found 7 syntaxia at that site, and at 36 other sites in the pool didn't encounter a single syntaxia. There was also a live juvenile crassidens at that site, which I'm sure is going to create a flurry of questions. And the site did have some other reproducing species. So down here, we've got Siphius, like I said, and Linealata. These are all very typical of the upper Greenup Pool. We found them at a lot of our more pristine sites like 209, which was surveyed twice, once in 2017 and once in 2020. In 2017, we collected over almost 1,100 mussels at that site, and then in 2020, we collected over 1,400 mussels at that site. So there was 2 or 3 sites up in the upper pool that had over 300 individuals per site and displayed a lot of these big river species that we commonly see in good habitat on the Ohio. So now we're looking at the PCA of the impacts within the Greenup Pool. We had 2 variables that explained over 70% of the variance. Those were the number or the distance from the CSOs in the pool and a site distance upstream of Greenup Lock and Dam. So here's our PCA of the impacts. You'll notice there is a big split right about here, right about river mile 309. That is right where Huntington is at. So upstream of here, most of our sites are fairly uninfluenced by tributaries, anthropogenic impacts. This is that upper pool section, like I said, 290, that's our really good site. All of these sites are well upstream of many of the historical impacts in Huntington. And then down here, we've got sites that are heavily influenced by CSOs and the Greenup Lock and Dam, which backs up the water. For roughly 10 miles, we found heavy silt deposits in the river that basically stifled a lot of the aquatic life. Here's a little better look at some of those variables I mentioned earlier. You've got the number of CSOs here, distance from major tributaries. These are all big driving factors. And then these are all in close relation to Greenup Lock and Dam. Interestingly, we see a big inverse of mussel abundance and diversity to our impacts, where you see most of the mussel diversity up here and very little potential mussel diversity below river mouth 307 or mussel abundance. So we're sort of seeing a strong inverse relationship between our impacts in the pool and mussel communities. And our eventual goal is to use this eigenvalue here as a predictor for mussel communities in the river. Ideally, you can do a desktop analysis, look at the number of variables, or the influences of the variables that I mentioned earlier, those 10 variables, and predict if you are likely going to find any unionid communities or not. So with that, please leave any comments or questions in the chat room, and we will try to get to them. Thank you.